By clicking the Add Milling Tool icon, we can select the type of tool to create for the operation. We will select Flat End Mill. Working from top to bottom, we must set the cutting diameter being used. We will use a 12 mm tool. Setting the cutting length is important. The Technology Wizard uses the cutting length to calculate if multiple depths are needed to achieve the pocket depth. We will use 24 mm. Setting the number of flutes is also important. Setting the correct number of flutes will ensure the proper chip size is given to each flute. We will use 5 flutes. The iData tab in the Tool table is used to define parameters specifically to iMachining. It is possible to set a different material database for each tool. The database will be automatically selected using the part default. Selecting a different material database is used when machining different materials in one CAM project. A fixture is a good example of this. We will leave the default. Selecting a tool material adjusts the cutting speed for a given type of material the tool is made from. The default is carbide at 100%. By selecting a different material, a percentage adjustment will be used to calculate the maximum cutting speed. An override checkbox is provided so that a percentage adjustment can be set manually. We will select carbide. Setting the default machining level will position the slider in the Technology Wizard to the level when selecting this tool. We will use 5. Setting the helical angle is important for calculating depths based on axial contact points, ACPs. There are 5 typical end mill angles to select from, or typing in a value can be used. We will use 45 degrees. After clicking Select, let's set the pocket depth to 30 mm. Now we can go to the Technology Wizard and see how values were calculated based on the tool information. Looking at the output grid, we can see the Technology Wizard calculated 2 steps at 15 mm depth to give us the 30 mm total depth. Notice the ACP value is set to 2 and the depth is painted green. Let's look at a fully modeled end mill and see where the 2 ACP value comes from. Here is the tool with the depth of 15 mm. We can take a sectional view of the contact area of the tool. Not counting the bottom point, we can see there are 2 contact points lined up vertically. This is where the 2 axial contact points come from. The green color for this depth in the output grid indicates that this is a good situation for stability. Now let's change the pocket depth to 5 mm. The ACP is 0.7 and the depth is painted red. Back to the model to see how the flutes line up vertically. There is no contact point above the bottom of the end mill. The 5 mm depth is only 0.7 of the next contact point. The red field indicates this is not a good situation for stability. Now let's change the pocket depth to 13 mm. The ACP now is 1.7 and is painted yellow. The model shows us that there is 1 contact point above the bottom and 0.7 of the next. The yellow is because we have at least 1 contact point above the bottom of the tool. Since there is at least 1 contact point above the bottom point, the situation for stability is okay. Now a depth of 14 mm. This gives us 1.9 ACPs and paints the field green. Even though the depth did not give us a perfect 2 ACP, there is a 20% tolerance on any ACP over 1. 0.9 of the next ACP is within the 20% tolerance, and the depth gets painted green for stability. Changing the diameter Number of flutes, helical angle, and or depth will have an effect on the ACP. The wizard calculates depths based on ACP. When specifying number of steps or step down value, the ACP number and the associated color will still be shown. It is not possible to always be machining with preferred ACP, but by monitoring the ACP value and the cutting results, over time you may find matching a tool to the current depth to get good ACP is beneficial.